Okay, we're doing chapter 7. The test is a review for our test. This is page 604. We have 1, 8, and 10 questions. So 1 says rearrange. So reading the directions, use an identity, simplify the expression. There may be more than one correct answer. Okay, so sine squared x. Oops, negative x. Minus 5, oopsies, secant squared x, cotangent squared x. Okay, so mine's written really badly. So what does the first one mean? So it's sine of negative x all squared, right? Is that good to start? What about, so Valen, you were saying something? So one of the identities, sine is odd, which means that you get the negative of sine of x, and then you're going to square it. Did I need to do all of that? Not really, because what is negative sine of x times itself? Positive sine of x squared. So that was a lot of work, but it explains where we got to here, and then I'm going to just call it sine squared x again. Boom. How about secant? How should I rewrite that? Okay, so I've got cosine squared on the bottom. How about cotangent? Cosine squared and then sine squared. How about that? So first, simplify whatever you can. This negative x was an issue. I handled it. Secant and cotangent are not in terms of sine and cosine. That's the first rule. Change them into sine and cosine. And then this cancels, right? So we can take that out. And now we have something, sine squared x minus 5 over sine, oopsies, squared x. So what do we want to do now? Can we do anything? We could make it cosecant. That's what they had in the back of the book. So for these, there'll be a goal for you, okay? And you'll have to show me all the steps to do the goal like we had on the second day of homework here. So there's nothing much you can do here. You're not trying to solve. So it's not an equation. You can't say equals 0 or solve it or anything. So there's not much else to do here except maybe move this back up to the top. The book gave this answer. And then sine goes with cosecant. They gave this answer. Thinking, okay, it's not a fraction, so that makes it more simple. But this is still in terms of sine, and this really is a fraction. So I probably would be okay here as well. What did we simplify? We simplified the cosine out, and we changed this to be regular x. Yeah. Yeah. So there are multiple kind of answers, but what you're going to have on the test is like a goal, you know, where we had equals something. And you're trying to make this side look like it. And if you skip a giant step, you're like, I'm not sure, so I'm just going to say, oh, it matches. Then I'm going to, you know, play I doubt it with you. That's what we call the card game. Did y'all play that game? I can't tell you what the other name for it is because it's not school appropriate, but we call it I doubt it in places where we can't. Yeah. Okay, so I'm going to call that on you. I doubt it. If you just skip steps, you have to show me all the steps. But you need to start with sine and cosine first. So that was 1. We added 4 to our list. 4 says, hey, there's a goal, okay? They're saying it is an identity, prove it. So this is more like what I would give you where you have a goal. You have sine squared x times cosecant squared x minus 1, and oopsies, forgot my goal, equals cosine squared x. So in this sort of setup, you're trying to prove it. You're going to leave this side how it is most of the time. I think there was one homework problem where it made sense to work on the other side too. But so what do we want to do? Okay, so you're going to know, and I have that sheet, and I'll pull that out in just a second. You need to know things like the odd identity up here for this one, the sine one. And I'll go ahead while we're talking about this needs an identity and find that sheet and what's starred or not starred. If you're watching this video, please pause it with this piece of paper so you can check and make sure you have all the same identities down. Oh Lordy, I hope I can find it. Here it is. Oh man, where's my starred one? Oh shoot. Here it is. Okay, so here it is, starred. So the things that are starred are the things you need to know because you already know tangent is sine over cosine or y over x. You already know these. We've talked about those a lot. You already know Pythagorean identity, but these other two weird ones I might give you. You already know, you should know even and odd. We had a discussion about that. And you can draw sine and cosine and tangent and see if it's even or odd. So you can figure this one out just by drawing it. Does it fold on y? It's even. Do you have to fold it and fold it again? Then it's odd. This rule. These you should know because you know what the period is. So it repeats every 2 pi. It doesn't matter where you start. If you add 2 pi to it, it's like wallpaper around the room. You can start anywhere in the room, right? And then when you put one whole sheet of wallpaper, that's the period. You should have a matching new piece of wallpaper on the other side. But you can start anywhere. That's what this is saying. This I would give you. Degrees to radian at the very bottom. We did that as part of chapter 6. You need to know that. It has a star. And then this whole side, if you needed something, I would give it to you. So we need that for number 8, I think. This other side. Okay, so is there a Pythagorean identity that goes exactly with this piece? Cosecant squared minus 1 equals cotangent squared. We could do that. Here it is. If you wanted. We could change this into sine and cosine, but it might be easier just to have one function. Do you see it? If I take cosecant squared and put the 1 on this side, are you with me? That means I could just write cotangent squared here. Instead of all this, I could write cotangent squared. What does cotangent squared mean? Cosine squared over sine squared. Are we done? Yeah, and that's it. So sine squared stays. Cotangent is cosine over sine. These cancel. You're left with this. Ooh, look, they match. So I'm going to have like a section of stuff that you'll need. You can go look for it and find stuff. But I'm not giving you sine squared plus cosine squared equals 1 because that's the most basic. And you've known that since 7th grade, except not in the terms of cosine squared plus sine squared. Anyway, that was 4. Now we're going to 8. 8 says, hey you, please find for me sine of 25 pi over 12. Do we know any 12s? We don't know any 12s. So what do? We have to find things that we already know and see if we can figure that out with an addition or subtraction identity. So those are not double angle, sum and difference. They're these. You would find that here, but you've got to find something that adds up to 25. So what do we have? 4 and 21. Does that work? 4 pi over 12 plus 21 pi over 12. Does that reduce anything I know? 7 over 4. Ooh, that does. I don't know. What did you find? 3 pi over 4 plus what? 4 pi over 3. So yours is 9 pi and then 16. So that works too. So there are different ways to do it. Why? Because these are periodic functions. So mine would have been 4 pi, oopsies, pi over 3 plus 3 goes 7 pi over 4. So 15 pi over 12 plus 10 pi over 12. So 3 goes 5 pi over 4 plus 2. 2 goes 5 pi over 6. So look, 3 different ways that you could add up to get 25 pi over 12. And they're all going to give you the same stuff because as you go around the circle, they have the same values. So we're looking for sine. So it doesn't matter which one we use. The sine one says, all of these were addition though, right? So the addition one says sine of one of them. I don't care which one we use. We'll use the middle one. Sine of 3 pi over 4, cosine of the other one, 4 pi over 3. Sine has the same sign, and then we're going to do cosine of the first one, sine of the second one. But you're going to be given that identity. You should have pulled out this sheet. Because we found addition, we find the sum and difference, and addition has the same sign, but sine and cosine are switched. So sine and cosine are flip-flopped. And then what do you know? You have to know the unit circle to get there. Yep. 3. Oh, yeah, I switched both. 3 pi over 4 goes here, and then they have to both be switched, or else I did the same thing twice, which is dumb. Okay. 3 pi over 4 goes with both. 4 pi over 3 goes... Okay, better. Thank you. And then on the unit circle, maybe you need to write down what the point is. 3 pi over 4, that's 1, 2, 3 pi, that's this one. So it is square root of 2 over 2, square root of 2 over 2, with the first one being negative. How about that? Is that correct? And then the other one is 4 pi over 3. This is 3 pi over 3, so this is 4 pi over 3. 4 pi over 3, that's going to be a half square root of 3 over 2, and they're both negative. And then once you have those points down, you just go collect your stuff. Sine of this one is positive. Cosine of this one is negative. Plus. Cosine of 3 pi over 4, this one, is negative. Sine of this guy is negative. Multiply it out. Negative square root of 2 over 4 plus, and that's still plus, square root of 6 over 4, 8. They wrote it in a different order. Or could you find in the multiple choice this value? Could you see they have the same denominator and that they just kept the negative with the square root of 2 but put it over here? Can you follow that math? Because it doesn't matter how you set it up. Any of these 3 ways would have found similar stuff. They all had a pi over 4 in them, pi over 4, pi over 4. That would have given you the right square root of 6s and 3s and 2s. So 8. 8 is the idea of, can you find this with stuff you know, given an identity that is already proven. And then 10, I think y'all made harder than it is. 10, if you read the question, back to the quiz, when I give you hints and stuff, I need you to read what they give you. 10 says this: use the sum and difference identities to rewrite each of the following as a trig expression of one single number, and then evaluate the results. So 10 actually required a calculator. So if I need you to use a calculator, I'll have a separate section of a couple problems. But probably for this problem on a non-calculator test, I'd just say, what does this mean? So first you had to write down what they gave you. So 10 said this. 10 said cosine of 131 degrees, cosine of 28 degrees, plus sine of 131 degrees, sine of 28 degrees. So what is this? This is, if you look through your work, the different practices that we've done, and you take into consideration 8 and 10, 8 and 9, hopefully were able to follow what was going on there, that this is an addition identity. So you go to your list of addition identities, sum and different, this is addition, and you say which one of these guys has cosine together, right? Which one has cosine together? Is it cosine or sine? So what they're asking you to do is, this is given to you in the identity form. What are you actually trying to find? You're actually trying to find the cosine value because it's cosine cosine. So you're looking for cosine. And then if it's a plus here, what does it actually mean you're doing with 131 and 28? You're doing subtraction. So do you see now what they're doing? And I totally do get how it may not be obvious to you straight up. And we didn't do a whole lot of practice here, but if you understand the purpose of the sum and difference identities, like working out number 8, then you're like, okay, this really indicates I'm trying to find the opposite, but it's cosine. So 131 minus 28 is 103, and then normally it would be something you'd know, like 90. And you could tell me what 90 is because you know where that is on the unit circle. So if it's 103, you'd have to use a calculator because no one knows what that angle is off the top of their head. So you'd have to put your calculator back into degrees, or you could say times pi divided by 180. But on a non-calculator test, if we were to have that, you should at least get here, given the identities over here. So they were asking you first to decide, it says, write it as a trigonometric function of a single number. That's what they mean by this. That part of the directions, does that make sense now? Okay. And then you'd have to go cosine of 103, and you'd have to either make sure your calculator's in degrees, or you'd say cosine of 103 pi over 180 because of that identity. And then whatever the calculator says is the answer. It is negative 0.2250. So this was a matter of, did you understand the directions or not? But also it's a matter of, do you understand the whole purpose of the sum and difference? Usually it's because this number is going to be something you already know, like 180 or 90 or 45 degrees, because you could make that pi over 4. So I would have made this question something obvious, like 45 degrees. If you had made this like 100 degrees and then this one was 55, two things I don't know, but if you combine them, that would have given me 45 degrees. That would have been a much better question in my estimation. But that's how you do number 10. Other questions? All right. So what you have for homework tonight is the rest of the chapter review. So it's not every problem. The problems are already posted. So I'll give you these problems, but you're supposed to work on those. We'll answer questions tomorrow. If you still have questions about your quiz or today's stuff, or look through old homework, look through the identity page, because even if I give you some, you need to be familiar enough to go find it, right? You need to be able to go, oh, this problem number 10 looks like the one that's addition. I can find it in the chart here. Well, I won't give you this chart because it has stuff on it that I think you should know, but you have to, it doesn't do any good if you can't recognize it. All right, so then we'll go over questions tomorrow, test on Wednesday.